Let me switch off my video. So today we are going to do this particular experiment number 5 in under EME lab, and the title of this experiment is internal combustion engine, or also known as IC engine. Okay. I agree that you guys are from diverse background. You guys are not from core mechanical engineering background. So I'll take things slowly, and I'll not impose anything quickly on you. But my agenda of this lab session is to let you understand uh, what these IC engines are and what is the working principle. Okay, how does it work and what is the significance? Means, I mean, yeah, essentially two agendas you can think of. And the aim of this experiment, although since we are on online mode, uh, we we cannot see physically what this IC engine would look like. Essentially, it is a container, or uh, where your piston cylinder arrangements are there. There is a crankshaft, things are moving, rotating, and some air fuel mixture is coming out, and it is on the completion of the cycle, things are going out from your exhaust silencer, and physically you will not be able to see it, but I'll try to explain things through scratch, so that at least you could have a feel of what the mechanical engineers are doing as such. So our aim is to understand and demonstrate the components. Also, we will be looking at the components. What are the different components that your internal combustion engine incorporates, and working cycle of internal combustion engine. So I hope that most of you know that what IC engine is all about. But those of you who don't know, your IC engine are the engines or a device that is fitted in your car or your bike, which provides mechanical power to run it, to run your wheels. Okay. We will look into each and every keywords. What do you mean by internal combustion? What do you mean by internal? There are some external combustion engines are also there. External combustion engines. What do we mean by combustion engine as such? What do you mean by engine itself? Okay, we will take things easily one by one in the subsequent slides. So before that, I want you to watch this YouTube video. Let me play this YouTube video for you guys. So in order to do that, let me include the computer sound as well. Sorry. Let me click this thing.
Good grammar and spelling are important, but if you want to write essays that inspire, messages that forge brighter connections,
So
and emails that
one
get the
second.
job done, you need to think
Please
about
stop.
more than just grammar and spelling.
One second.
This sentence is grammatically correct, but it's wordy and hard to read. It undermines the writer's message, and the word choice is bland. Grammarly's cutting-edge technology helps you craft compelling, understandable writing.
Okay,
A car engine generates power from
are
the
you guys able to
expansion.
see my YouTube video and its sound as well?
Yes, sir. Yes, sir.
Okay, so let me full screen it and let me run this video. This is 4 minutes video, and this is would be very helpful to understand why and what are the things and what is the working principle of IC engine. What is IC engine? How does it work?
Of compressed air. A car engine generates power from the expansion of compressed air in a contained cylinder with the help of fuel. That is why it's called as an internal combustion engine. Before getting into the working, let's see the main parts involved in the working of an engine. First, the crankshaft. This is the part which converts the linear motion of the piston to a rotational force. Next, the pistons and the piston rods. The pistons will be pushed down by the expansion of compressed air, and turns the crankshaft. And the valves, which controls the flow of air and fuel into the cylinders. These valves are driven by the intake camshaft, and the exhaust camshaft, and the camshafts are driven by the crank itself, using a timing belt. There will be idler pulleys, and a tensioner pulley, to hold the belt tight in place. This here, is the internal structure, of a 4-stroke, inline 4-cylinder, DOHC engine, which is commonly found in most hatchback and sedan cars. A 4-stroke engine should pass through 4 different strokes, to complete one cycle to produce power. They are intake, compression, power, and exhaust stroke. The crank to camshaft ratio is 2:1, which means it will take 2 crank revolutions to complete 1 camshaft revolution. And the camshafts are designed in a responsive manner to open or close based on the corresponding strokes of each cylinder. Let's take a look at a single cylinder and see how a 4-stroke engine works in detail. In order to ignite the air-fuel mixture, a spark plug is used. This will ignite the compressed air-fuel mixture, with the help of an electrical spark. We will take it down by each stroke. The intake stroke. The inlet valve opens and the downward movement of the piston creates a suction. This pulls the air-fuel mixture into the cylinder. Once the air-fuel mixture is in the cylinder, compression stroke begins compressing the mixture. At this time both inlet and outlet valves stays closed. At the end of compression stroke, the air-fuel mixture is ignited by the spark plug. The explosion exerts pressure and pushes the piston down. This is the power stroke which produces power to the crank. At the exhaust stroke, the outlet valves opens and the piston pushes out the burned gas. The cycle starts again from intake stroke, keeping the engine running and produces power. For a carburetor engine, the air and fuel are mixed inside the carburetor assembly, and fed to the cylinders. In the case of a fuel-injected engine, the fuel is injected into the intake manifold, or directly into the cylinders. Since only a power stroke produces power, you may wonder how the engine turns continuously. Well, the answer is in the crank itself. The flywheel and the crank counterweights provides momentum, which keeps the crankshaft from stopping immediately. For a 4-cylinder engine, considering any time instance, one cylinder is always in power stroke, which produces more power and less vibrations comparing to a single-cylinder engine. And that is how a car engine produces power in simple. Thanks for watching, and stay tuned for more presentations from Auto Cycle Labs.
Okay, I hope that this slightly give you an idea of what the internal combustion engines are all about, and what is the working principle. And uh, just to give a brief of what is the working principle, how does it work. So let me go ahead and let me start with the introduction. So the first keyword we encountered is are the engines. So engines are the devices or system used to produce net power output are called engines. So any device which can give you advantageous mechanical work or mechanical work is called engine. And the next keyword that we often encounter are called heat engines. So there are several categories of heat engines. This category, which IC engine is all about, is it falls under this category called heat engines. And we also talked about in our previous discussions that we have um, heat engines sitting over here. It takes certain amount of heat and it produces some amount of work out, and in turn it also leaves behind certain QL, which we have already seen our previous labs. Okay, so this heat engine sitting over here is nothing but your, essentially in real life it is your IC engine, okay, which takes some sort of heat inputs. So far we considered in our previous labs that this heat engine which were sitting here is kind of black box, but in this particular lab we are going to get a detailed view of this, whatever the cycle that it undergoes, whatever the cycle it undergoes. Let's suppose this is my PV diagram. So we will look closely in this particular uh, lab session that what this black box is all about. And in previous labs, we do not care what's happening inside, but now we will take care of what things are actually happening inside this black box. This lab is all about uh, reading what's happening inside this particular black box. Okay. And we used to find efficiencies based on your desired output workout divided by QH, the heat input. So we were all only considered about the efficiency of this black box, but here we will talk about how this particular guy takes up some sort of heat addition process and leaves certain amount of heat, and in turn it produces some advantageous workout. And this was your called your heat engine. So heat engine, the formal definition of heat engine is a heat engine is a system that converts heat or thermal energy to mechanical energy. It means you take advantage of some sort of input. Let me, one second. Okay, it takes advantage of some sort of, let's suppose you have a source is what your petrol or your diesel is going to be ignited with chemical combustion, and through the combustion process you get the heat, and which heat is it is taken by some sort of device over sitting over here. And what this device that does that cleverly, it produces some sort of work output to you, and this is our main goal. So it converts heat thermal energy to mechanical energy. Okay. It can be used to do mechanical work. So essentially यहाँ so so let me go one step behind. So let's suppose you have a piston cylinder arrangement over here. You have a piston, you have a crank, and the crank is rotating, and fuel is coming. It is going to be ignited. So this is your gas and fuel mixtures are igniting over here. This is your piston, and this is going to and fro. While going to and fro, this crank is going to this is your crank, and this is your connecting rod, and this particular connecting rod, this crank is going to be rotated with some certain omega. And now in principle, this point is being connected with some sort of gear arrangements, and through some shaft and gear arrangements, gears uh, through these gear arrangements. So let's suppose this is your gear with some sort of gear combinations or gear trains, and in turn it is connected to your wheel. Okay, this is your wheel, and now this wheel, so because this has some power and this is being transmitted to wheel, so wheel is going to be rotated, and once it is going to rotate, because of the friction, uh, on the road and your wheel tires, your car is going to move forward. And this is how a typical flow process, you can say, uh, flow process of the energy from uh, thermal energy, it is going to be combusted, and this thermal energy in turn is being converted to your mechanical output, and in turn you are going to, through that mechanical advantageous power, you are going to move your car uh, ahead, isn't it? So this is the whole process that you can think of. Again, this heat engine can also be classified as a reciprocating heat engine. So also often known as piston engine. It is typically a heat engine that uses one or more reciprocating pistons to convert pressure into rotating motion. You can see there is some pressure, that the fuel air combustion that is happening, some pressure. Because of this pressure, oscillating pressure, uh, your piston is going to move up and down in reciprocating manner, and that is why it is also sometimes called a reciprocating heat engine. One more thing, in the animation that I have shown you, it has shown you uh, four pistons. Okay. So essentially in your car you will have uh, generally you have four pistons clubbed together. So this is only one piston or one block, and there are four blocks that are sitting over, I mean, in your car. Maybe in your bike, maybe two pistons are there or one piston, but in your car you have four pistons and four stroke manner. So I'll also talk about what this whole stroke is all about in the subsequent uh, slides. So essentially you have in your car, you have four piston and four stroke engine. So that is why it is named as four piston, four stroke. Four stroke, what does it mean? In one cycle, your reciprocation of this piston happens to be to happen four times in one complete cycle. Okay, and what is cycle? I will talk about thermodynamic cycle as well in this particular, I mean, thermodynamic cycle in this particular lab session in subsequent slides. Okay, one more thing, key point to remember is this whole process that we have talked about, this whole process uh, we have talked about here is having single working fluid, and its phase is not changing. Phase is not changing. मतलब मेरा अगर एयर गैसियस फेज में है तो गैसियस फेज में ही हमेशा रहा, और यही मेरा चीज़ों को पुश कर, आई एम सॉरी everyone, I mean, anyone who does not understand Hindi here, you can raise your hand, otherwise I may keep switching Hindi or English in between. So any foreign students here, anyone of you? So this I can see Malaysia, Ghibli one. I mean, this guy is a foreign student, so I should not skip. I mean, I should not keep myself putting into Hindi. Okay, I'll keep myself in English itself. Fine. So what we saw here is we have single working fluid, and phase is also not changing uh, in due time. So that is why it is it is also called gas power cycle. So the cycle, the thermodynamic cycle that it involves is also called gas power cycle. So another cycle that we have in textbooks is uh, vapor pipe power cycle. Vapor power cycle. Okay. So these vapor cycle power cycles will have water plus vapor. So essentially, water is is a single fluid that is being used in your power plants. So if you go to some power plants which generates electricity, it essentially uses water as your working fluid, and water and vapor is being continuously switched back and forth. The phases are being continuously back and forth changed in certain manner. We will not talk about it here, but you should know that there are other cycles as well, and it has certain advantages and disadvantages. Okay. So with this water and vapor cycle, sorry, this vapor cycle, you are going to rotate your turbine, and your turbine is connected to your some sort of uh, you can say converter or generator which generates electricity. So in turn, so there I am taking advantage of my thermal energy to run to produce electricity. But here I am going to produce uh, I mean take advantage of thermal energy to do some mechanical work or just to run my car or bike. One more thing is we also talk about internal combustion engine. So internal means your combustion combustion happens internally, as name suggests, internally. um, but in some cases, such as in power plants, you actually um, do the combustion somewhere outside from boiler or some sort of other arrangement. You take to those combustion products into your feed, and then you uh, do some thermodynamic advantages, and then rotate your turbine, and then in turn generate electricity. So that those sort of things are called uh, external combustion engines. Okay. So in this particular lab session is all about internal combustion engine. So we should be sticking with this particular these definitions. Let me move forward, and let me try to give you the motivation by telling you that the first commercial successful internal combustion engines were created by Lenoir around 1860, see 150 years back. And still this the the development of good and better engines are still in process. So it's been 150 years, and this changes our modern uh, civilization a lot. I mean, this impacted our this revolutionizes everything, isn't it? Things where um, you are going to be transported, or you can transport things by no time, with no time, right? So things are, I mean, before that things were so uh, time consuming, but after this point of time, things were revolutionized. And the first modern internal combustion engine were created 1876 by Nicholas Otto. And this, based on this mathematician or physicist, we have a thermodynamic cycle called Otto cycle, honored on this particular guy's name. We have Otto cycle, also called SI engine cycle. Okay, we'll look into it uh, more closely in the due slides. So these are the components you would look in a typical IC engine. Okay, so this is your crankcase. First of all, this is your crankcase. This is your casing, you can say, in which your one piston is being, piston cylinder arrangement is being put, or crankshaft arrangement is being put. This is your piston. Okay, and this is the connecting rod, and this is your crankshaft. And once this is being rotated, and this is being connected to some other arrangements, and which is connected to your wheels. And okay, fine, and we can start with on top. So on top we have intake valve. So this particular guy over here is intake valve. So intake valve, what it does is intake valve, and we have an exhaust valve as well. So valve, what is the purpose of valve? So valve, the purpose of valve is pretty straightforward. It so it takes things in one direction, and it does not allow things to move in another direction. Like your in your heart also, the blood flows in one direction, and when things have been uh, processed, it will not go back. So there is a valve that does not allow things to process in opposite manner. So it always allows things to come from this side, and then valve stops, and once the combustion and stroke, the power stroke has been done, the cycle has been complete, the exhaust gases move through this way, and so it happens to be done because these valves are synchronizing are in synchronous with the cycles that are associated. तो एग्जैक्ट टाइमिंग पे ये खुलता है, ये बंद होता है, ठीक है, तभी ऐसा हो पाता है. ओके, दिस इज योर कंबशन चैम्बर. दिस इज योर कंबशन चैम्बर वेयर योर कंबशन इज हैपनिंग. ओके, this is a cylinder block. This is your connecting rod. Fine, cooling water. Okay, and in general the temperatures also reach very high, so to say 600-800 degrees C. So that may cause melting of your casings. So in order to cool things, you have a circulating cooling waters that are also provided. Maybe in on top of it, it might be circulatory way. So cooling waters are here. This is your cylinder head, spring valve. So spring valve allows you to move this valve in synchronous manner, and this, it happens to be done through a, a very clever kinematically way, and that is the device we use to do it in synchronous manner is cam. Basically cam does it. We will not go into the details of it. You just need to know that what are the components that are there. And we have a very important component called spark plug for petrol engines. Okay, I did not talk about, there are two classifications of IC engines. So one is petrol engine, another is diesel engine, and these two differ by its working principle and the working fluids. Okay. So we first talk about petrol engine. The main difference of petrol and diesel engine is it uses a spark plug. It does not uses, and it uses fuel injector, and it does not uses, and the combustion happens because of the spark plug, and here combustion happens because of the high pressure that are there in the process. Because of the high pressure, the pressure is so high that fuel and air abruptly combusts here, but here you need to combust it through some sort of spark plug. That is what it is all about. Obviously the working fluid here, working fuel is used here is petrol, and here it is diesel. both are byproducts of your raw oils, petroleum oils. Okay, and fine. Let's move forward, and this is a schematic of what we have just shown in our YouTube video. So it essentially have a four sort of a cycle. A full cycle consists of four uh, components. One is intake stroke, another is compression stroke, next is combustion, and then it is exhaust. So you can keep a track of your timings as well. During this period from one, it is intake stroke. Now it is intake stroke. Now things are coming. Now it is going compression, and then combustion, and then exhaust. So the whole cycle is being depicted over here. Okay, if I talk about on the cycle, let's talk about on the cycle or on a graph what's happening here. So let's suppose I have a pressure and volume plot. I am plotting pressure inside this guy over here, and the volume that it contains. So I'm going to plot pressure versus volume, and we start with intake stroke from some certain way. Let's suppose V1 and V2. I have two volumes. So this is the least volume I have, this is the highest volume I could have. So it starts with least volume, and the intake strokes goes something like this. Intake stroke goes something like this, and then it moves this fashion, and essentially this is isentropic in nature. I don't want to confuse you guys, but there are certain thermodynamic processes such as adiabatic process, isentropic. Right, isentropic means constant temperature, sorry, constant entropy process, uh, which goes from, let's suppose, 1, 2, then 3, uh, then you have the heat addition. The combustion happens, heat addition happens at constant volume, and then it comes back. This is your power stroke, which gives you power, and this is the heat addition, that the fuel burns and heat is being added, and then it comes to the original place with this 1, 2, 3, 4, 5, and 6. So this is a typical cycle that we will extract, and we will talk about this in detail. And this is nothing but ideally, so this is a real cycle, but ideally it is being assumed as an Otto cycle with some thermodynamic uh, components that are involved. Means isentropically it went, then it has been isochorically the heat has been added, then isentropically the compression, the expansion has been done, and then isochorically things okay, exhaust has been, the Q out has been put out. So this is through this, the reason being we actually promote these sort of graphs is because just by looking at this graph you can have all sorts of information such as your work output, just by PV diagram. Usually PV diagram, integration of P delta V will give you work out, and just by looking at the plot you can actually have a feel of what power output your engine will have in one shot. So that is why these sort of graphs are more important, or uh, uh, qualitatively it is more important to understand. Okay, let me go one. We have one more animation. So this one by one thing is being plotted by this dot from where it is going. So you can see intake is happening, and then it is compression, and then heat addition, and then power stroke, and then exhaust. This is how in one complete cycle this thing is being happening. Okay, now since we have done the dynamics, we have seen the dynamics of the reciprocating or the IC engine. Now let's look at every there are certain you can say key key notations. So we as an engineer we define something. So we define something that uh, the least the least uh, you can say the least length it can come here is this position, and the uppermost the piston can go this particular guy, I mean this particular line, and this line is called BDC, and a top line is called TDC, top dead center and bottom dead center, and the length between these two uh, key notations is called stroke, and the diameter is called bore for this piston cylinder arrangement. So we have certain notations such as top dead center, the position of piston when it forms the smallest volume in the cylinder. Okay. Obviously, when this piston is over here, let's suppose this piston has occupied here, so you have the least volume with you. At bottom dead center, you will have the highest volume. When the piston is here, you have the highest volume, largest volume with you. The stroke is the distance between TDC and the BDC, and the largest distance that a piston can travel in one direction is called the stroke of engine. So this length is called stroke. Bore is the diameter of the piston. Okay. So since this is a circular, in general this is a 2D sketch, but in general this would be something like this, and your piston is also some sort of cylindrical in nature. Okay, so in general you have a certain diameter over here on top, so this is called bore. So you just have to you don't have to mug these things, you just keep things in mind that these things are there, and you should know this at least. I mean, if you are going through this particular course or this lab, you should know these things at least. We have something called intake and exhaust valves. So this is your intake valve, this is your exhaust valve. So air or air fuel mixture is drawn into cylinder through these valves, and combustion products are expelled from cylinder through exhaust valves. And so this is your intake, this is your exhaust, and this is being connected to your silencer and all to let the absolute air outside to the environment. There is something called clearance volume. The minimum volume formed in the cylinder when the piston is at TDC is called clearance volume. So when your piston is at TDC, whatever the volume we have is called the volume will have this V is called the clearance volume. Displacement volume, whenever your piston is at bottom dead center, whatever the volume you have. Okay, sorry. So the displacement volume is the negative of the total volume minus this TDC volume. So the regular volume we have, used volume, is called displacement volume. The volume displaced by piston as it moves between TDC and BDC is called displacement volume. You just don't have to mug this thing. There is another key notation or the key feature of to judge the performance of any engine is compression ratio. Also we have efficiency in our hand, efficiency and compression ratio, which is depicted with R. So with these two components or with these two variables, we usually judge our engines. Okay, so this is nothing but the ratio of maximum volume formed in cylinder to the minimum clearance volume. So basically VBDC and VTDC इसका जो ratio होगा, this is called compression ratio. Okay. This I will not cover MEP वगैरह. Okay, we don't have much time, so we will not cover. But just to give you idea of what MEP is, so mechanical effective pressure. So whatever your work output would be, hypothetically what we think of that we have a P average, some sort of P average, and then we make the judgment of this P average, and we try to match this area with this area, and while doing so we will have certain formula for that, MEP times piston area times stroke and MEP times displacement volume, and which allows me to actually study the things. Since your pressure is varying a lot, see, your pressure is varying a lot, so अभी क्या है, इसका स्टडी करना मुश्किल हो जाता है. We have the difficulty in studying when your pressure is varying. So what we usually do while studying things or observing things, we hypothetically judge that yes, चलो इतना प्रेशर मान लेते हैं, इतना है, और सेम इफेक्टिव अगर प्रेशर वर्क सेम हो रहा है तो I mean we will be in the same line. Okay, we don't have to worry much about it. We don't want to talk about it much here. Okay, this is the same thing which we have already talked about. This is a typical Otto cycle. This is actually this is not, this is a real cycle, real IC engine cycle. So we have a intake, we have a compression, ignition, end of combustion, expansion, and then come to the same place. So what we do here is for studying this sort of this is a complex graph. What we do is we assume that my cycle is happening hypothetically, but in the same way my cycle is happening slightly this way. So we start from here 1, isentropically we go at 2, then volume is kept constant at 3, then we come back at 4, and then isochorically we come back. So we replace, or we just by in order to study things in easy manner. Not only easy, but also thermodynamically it makes same sense. We just extract this particular guy and we approximate this graph with this graph, and this graph is known as Otto cycle. Okay, and this is easy also to do because we left things, unnecessary strokes out of the picture, and this does not leave any physics behind the process. Okay, physics भी इंटैक्ट रखते हैं और easy भी हो जाता है, तो हम लोग उसको ऑटो साइकिल से जज करते हैं. So there are fine. So this is what I am talking about. This is your real cycle, and this is your Otto cycle that I have talked about. So this particular cycle is approximated by this cycle, this PV cycle. Pressure and volume plot पे हम दिखाते हैं. So we start from 1. So we believe that although compression is happening, so we believe that this is an isentropic compression. Okay, we usually approximate it this way. This is isentropically, so that thermodynamically we have advantage of writing some equations. इसका equation लिखने जाएंगे तो पूरा दिन रात हो जाएगा. But this is a more approximated way to look upon it. So isentropic compression 2 पे गए. Then we have okay. So we have a heat addition. So we don't believe that, and not believe, I can say, we don't really think of that things are combusting here. We just think approximately that some Q in is just added here. Okay, hypothetically just Q in is added here. Isochorically means volume is kept constant. At the same moment when the piston arrives here, the combustion happens quickly within few seconds, and within that moment things, Q in has been added, and it goes to state 3, and then power stroke isentropically again, and then exhaust. Q out is being happened, and in between we have the area under the curve. The area under the curve is nothing but your work out. So you can see this is nothing but your heat engine that is sitting over here. So it is having some sort of Q in and some sort of, let's suppose this is my black box. some sort of Q in is happening, some sort of Q out is happening. In turn, you are getting work out. Isn't it beautiful? The same heat engine, I have discussed it here with the proper cycles. And initially we were looking at this heat engine by a black box. Okay, I will not talk about, this is my theory class lecture, but I will not talk about thermodynamic analysis of Otto cycle. But the purpose of thermodynamic analysis of Otto cycle is to estimate the efficiency. That's it. So just to give you a formula, we will not go into the details of how this has come, but you just have to take care of this formula. This formula tells that the efficiency of Otto cycle is nothing but 1 minus 1 upon R to the power K minus 1, where R is your compression ratio and K is the specific heat of air. Specific heat ratio, ratio of air, that is gamma or K. So gamma is Cp by Cv. That's it. So इस फॉर्मूला से हम लोग efficiency निकाल सकते हैं. That's it. So what I will give you guys is so I'll okay, at the end I will tell you what assignment should we take. So let me finish it within 2 minutes and then I'll give you the assignments or the lab files what you have to submit. So people have seen that, people have verified, so people have varied this compression ratio from 1 to 14 and people have seen that within this range, the efficiency of Otto cycle is better. After that, basically after 10 or 12, the compression ratio is not feasible because of your physical constraint of your materials that may fail. Okay, after that it may fail for higher compression ratios. So this is the optimal range you could think of. Okay, and again, we are talking about petrol cycle. Now we'll talk about diesel cycle. So the main difference of diesel cycle and petrol cycle is, so this is your petrol cycle, this is your diesel cycle, diesel engine. So main difference is through fuel carburetor. There is a device called carburetor. You are going to mix your fuel and air in certain stoichiometric way, and then the air fuel mixture is being combusted through the help of a spark. So the mixture should be in some sort of stoichiometric way, so that chemically it should be proper, then only it will combust. Okay, you should keep in mind in petrol engine. Whereas in diesel engine, you will have a fuel injector directly in your volume, that is here fuel is being sprayed, and because of the piston, the cycle pressure is so high that it auto combusts. Okay, you don't have to worry about much. So the main difference I'm going to talk about is, let's suppose this is your petrol and let's talk, and this is your diesel. So the petrol cycle, we have seen that it goes from here to here, 1, 2, then heat addition at constant volume. So this is my PV, again this is your PV, and this comes down and this comes down. So this is your complete cycle that you could think of, 1, 2, 3, 4. Whereas in diesel cycle, we have same isentropic compression 1 to 2, but here what happens? 1 to 2, the pressure goes high and the heat addition takes place at constant pressure rather than constant volume. So here it is constant volume, here it is constant pressure heat addition, then it comes back and then it comes back. So two processes are constant pressure process, 1, 2, 3 and 4, and here two processes are constant volume process. That is the only difference, that that is the thermodynamic difference between petrol or Otto cycle with diesel cycle. That's it. And this has been devised by Rudolf Diesel in 1980 after petrol engine has been discovered. And I will not go into the details because most of the principles are same. Again, you can see 1 to 2, 2 to 3 heat addition is being happening, Q out is happening. Again, this is your this area under this curve is workout. Again, you can think of it as a black box, Q in, Q out, workout. You are getting on PV diagram. These are the thermodynamic analysis, and the efficiency of diesel cycle comes out to be this. But don't worry about this formula. I don't want. I will not ask you these things. Okay, so fine. So let me go back and let me tell you what our assignment could be. So I mean, any idea? I mean, so far, what I think of, you go. I mean, probably I believe that everybody of you might be having at least your at your home you have a car or a bike. Okay, any car, any bike. Okay, it may be petrol car or diesel car. Okay, you just go and either Google it or you just go and find uh, that what engine you have. Okay, how many pistons you have in your car or your bike. Okay, whether it is working on Otto cycle or diesel cycle, whether it is 4-stroke or 2-stroke. Okay, you have to list it out. What are its efficiencies, if at all you have efficiencies, you have to look upon, you have to check upon. Okay, and make a report of it. Can you do that and try to so when you are making report, try to take a picture of your engine also. Okay, take a picture of engine and paste it in your report, that this is your engine, you find it, this particular is my engine, and things are there. And also, if at all you are able to identify some of the components, if at all, try to do that. Okay, can you make this thing? I mean, is it easy, is it hard, or you want to do something else? Anybody? And was it understandable? I mean, क्या समझ में आया आप लोग को जो हम समझाना चाह रहे थे एटलीस्ट?
यस सर।
ओके, तो आप लोग कैसा असाइनमेंट करना चाहेंगे? जो असाइनमेंट हम दिए अभी, ऐसा करना चाहेंगे? आपके रेस्पेक्टिव घर में क्या कार बाइक है, उसका इंजन के बारे में एक पैराग्राफ लिख पाएंगे? हाँ, नहीं, यस, नो, एनीबडी?
मतलब सर
हाँ,
ये जो पढ़ाया है वही लिखना के दूसरा कोई?
यही लिखना है आपको। आइडेंटिफाई करना अपना कार, आपके घर में जो कार है, कार का मॉडल ये है, उसमें ये इंजन है, you find this engine, you find this as a 2-stroke engine
और उसके बारे में थोड़ा सा लिखना है
हाँ,
ऐसा?
थोड़ा सा लिखना, फोटो डाल दीजिए और कुछ 1-2 कमेंट्स लिखिए, और क्या सीखे वो सब भी लिख सकते हैं if you want.
And
और
sir,
दूसरा
can we do this
एक
in
समरी लिख
Word?
सकते हैं.
Sir,
You
can we do this
can
in
write a
Word?
summary what you.
सर लास्ट टाइम वाला बेटर था असाइनमेंट सर, जो
क्या?
हमको सर ने दिया था वो वाला, तो फिर
क्या दिया था?
मैं तो वही प्रेफर करूंगा।
क्या दिया था सर ने?
सर ने एक पीडीएफ शेयर करी थी, उसमें से जो टेबल होगा वो फिलअप करना और कैलकुलेशन करनी है और बाद में डिस्कशन लिख देना है और सबमिट कर देना है।
Okay, let me see what table they have given. Let me go back and see. They might have given. Let me see. Experiment number 5 है ना? Let's see. इसमें कोई टेबल है ही नहीं एक्चुअली में, ठीक है? इस पर्टिकुलर लैब में कोई टेबल है ही नहीं, तो हाँ, तो हमारे पास हाँ,
Whenever we are having a table, we have added the table over there. And if we are having some calculation, we have shown there. And if graph is to be made, graph is also there. And all this, but we have done in Word and graph in Excel. Because
fine. You do that. But
that
thing is, here in this particular lab, we don't have any tables.
Sir, so we can add a page in this PDF of regarding summary. that what
हाँ.
we have understood from this experiment, and
Summary.
we can take as a sample input as our own car.
Exactly. Thank you हरदीप. So ठीक है, हरदीप ने जैसा बोला, let's keep it that way. हम लोग एक समरी लिखेंगे. We will take up, we will make a summary, and we will also take up as example as our own car that we have in our parking, and we try to find it, whether from Google or whether by looking at it. बोनेट खोल के एक बार देखिए क्या इंजन है, नहीं है, समझने की कोशिश कीजिए. Okay, and let's write a summary.
And
Sir,
sir,
but
in this,
exactly what do we have to write?
Summary
sir,
लिखना है. क्या
sir, we
summary?
can write that what type of engine is there and which
Exactly.
stage it is and all that thing.
4-stroke है. So you make a listing. It is having 4-stroke or 2-stroke. Your engine is having 4-stroke. Fine. You find it somewhere in your.
CC and all that thing we can
हाँ
write.
हाँ, कार का वॉल्यूम देख सकते हैं कितना है, उसका स्ट्रोक लेंथ कितना है. आप उसके कार के मैन्युफैक्चरर के साइट पे जाके देख सकते हैं.
ट्रैक्टर का भी चलेगा ना?
किसका?
ट्रैक्टर
का. हाँ ठीक है, ट्रैक्टर का भी चलेगा. ठीक है, फाइन, दैट्स ग्रेट. उसका भी हाँ एक अच्छा रिपोर्ट बन सकता है. ट्रैक्टर में कुछ चीज़ें और सोचता डिफरेंट हो. गुड वन कीजिए आप लोग. तो आई
वो
बिलीव
टेबल
सबके
वाला
सबके यहाँ कुछ ना
पार्ट
कुछ
क्या है?
होगा. हाँ,
टेबल वाला पार्ट एक्सप्लेन करो ना.
टेबल वाला. टेबल इसमें है ही नहीं,
हाँ.
टेबल लिखना ही नहीं, समरी लिखना है. फिर
Okay.
लिखना है कि हम क्या पढ़ा है आज. ठीक है, वो
Okay.
समरी करके लिखिएगा. ठीक है, मेनली मैं जज करूंगा इसको वाइवा में. वाइवा में 1-on-1 जब हम पूछेंगे तो समझ में आ जाएगा कितना समझे हैं. पर फिर भी आप लोग एक ट्राई कीजिए.
सर अटेंडेंस ले ली?
हाँ, अटेंडेंस हम ले लेते हैं, पर ये अटेंडेंस क्यूमुलेटिव अटेंडेंस है, तो हमको पार्ट 1 पार्ट 2 का अटेंडेंस अलग से नहीं मिल पाएगा. बट लेट मी डाउनलोड दैट. 1 सेकेंड. डेट कितना है? 5 मई. ओके, सो हम
So
ज़्यादा
can
टाइम
you
के लिए हम
create a assignment in Teams and let us know that when is the deadline?
हाँ, 1 सेकेंड. तो अभी जो मैंने टीम्स बनाया है, ये टीम्स पार्ट 2 के लिए. तो आप लोग पार्ट 1 वाले अभी सबमिट नहीं करेंगे, हम लिंक अलग से देंगे पार्ट 2 वालों को. ठीक है,
1 sir.
सॉरी, पार्ट 1 वालों को. आई एम रियली सॉरी. हाँ, पार्ट 1 वालों को. तो अभी जो व्हाट्सएप ग्रुप बनाए हो उस पर हम हो सकता है लिंक शेयर कर दें कि यहाँ सबमिट करना है आपको. ठीक है,
Okay sir.
ठीक है. अभी फ़िलहाल आप लोग अभी ऐसे ही रहिएगा. और पार्ट 2 जो है, मतलब मेरा जो यूजुअल बैच है, वो अभी उसके लिए हम डालेंगे. उसमें पार्ट 1 वाले नहीं डालेंगे अभी. ठीक है
सर, वर्ड फाइल सबमिट करने की ना?
हाँ, वर्ड फाइल कीजिए, उसको पीडीएफ बना लास्ट, लेकिन पीडीएफ रखिए क्यों आसान होगा खोलने में मुझे.
ओके.
ठीक है, चाहे तो आप हैंड रिटन में लिख के स्कैन भी कर सकते हैं. आई मीन आई एम लीनियंट है ना. ठीक है, हैंड रिटन करके स्कैन भी कर
सर
सकते हैं.
हमारा नेक्स्ट क्लास शुरू हो गया है.
फाइन. यू मे, आई मीन लेट्स लीव दिस मीटिंग देन. आई एम सॉरी.
Okay sir. Thank you sir.
थैंक यू. हाँ, थैंक यू.
थैंक यू सर.
थैंक यू सर.
Thank you, sir.
थैंक यू.
Thank you, sir.